My name is Catherine Staltair, and this is my partner, Ed Farron. Today, our subject is fractions, Part 1.
We saw earlier that when a pi is divided, 1/2 equals 2/4, which equals 3/6, and so on. This leads us to the idea of reducing fractions. Let's look at the fraction 3/6. If we divide the numerator and the denominator by 3, we get 3 divided by 3, which equals 1, and 6 divided by 3, which equals 2. The new fraction is 1/2, or 1/2. 3/6 equals 1/2.
The following rule is true. When the numerator and denominator of a fraction are divided by the same non-zero whole number, the result is an equivalent fraction. This is called reducing a fraction.
Like losing some fat.
In some way, some unnecessary fat. The person stays the same, the fat goes. Here too, the fraction's value stays the same. The terms of the fractions are reduced, but not its numerical value. Now, let's reduce the fraction 15/60. 15/60. This can be done many ways. We could divide the numerator and denominator by 5. 15 divided by 5 equals 3. 60 divided by 5 equals 12. So the original fraction, 15/60, equals 3/12.
We could reduce 15/60 in other ways too. Divide the numerator and denominator by 3. 15 divided by 3 equals 5. 60 divided by 3 equals 20. So, 15/60 is also equivalent to 5/20.
When there is a number which divides both the numerator and denominator evenly, without remainders, as do 5 and 3 in the previous problems, we refer to it as a common divisor or common factor. A factor of a number is another number that divides into that number evenly, without any remainders. 5 is a factor of 15, since 15 divided by 5 equals 3. 3 is a factor of 15, since 15 divided by 3 equals 5, with no remainder.
A common factor of a set of numbers divides each of the numbers in the set evenly. When a fraction is reduced, the numerator and denominator are divided by a common factor.
This sounds complicated, so let's do a problem. I'm sure it will help make this clearer. Now, we'll reduce the fraction 30/120 to an equivalent fraction. We want to reduce to lowest terms, or to the smallest possible whole numbers in the numerator and denominator. Let's first divide by 2, a common factor. This gives the result 15/60. To get to lowest terms, we continue to divide by common factors. Both 15 and 60 are divisible exactly by 5. So 5 is a common factor. Divide numerator 15 and denominator 60 by the common factor 5. This gives 3/12. But we're not finished. 3 and 12 have a common factor, 3. Divide numerator and denominator by 3, and the result is 1 over 4, or 1/4. No further reduction is possible. The only common factor of numerator and denominator is 1. The fraction 30 over 120 has been reduced to lowest terms, 1 over 4.
A fraction is in lowest terms if the numerator and denominator have no common factors other than 1. This means that the fraction has the smallest whole numbers possible in its numerator and denominator. Let's see examples of fractions in lowest terms so that the idea is clear. 1 over 10, 1 over 200, 1 over 1,000 are all in lowest terms. In each fraction, the only common factor or divisor of the numerator and denominator is 1. 2/3, 3/4, 4/5, 7/8 are in lowest terms. 3/5, 11/18, 9/22 are all in lowest terms. They cannot be reduced further. Here are some fractions not in lowest terms. 2/4, 4/10, 10/15. They all have common factors and can be reduced.
When we reduce a fraction, we usually don't write out every division by a common factor, as we have done until now. We can use slashes through the numerator and denominator to show the process. Let's demonstrate this notation. Reduce 30 over 120. Divide 30 and 120 by the common factor 2. Put slashes through 30 and 120 and write down 15 and 60, the quotients of the division by 2. Now, divide by 5. Put slashes through 15 and 60, and write down the quotients of the division 3 and 12. Finally, divide 3 and 12 by 3. We get the quotients 1 and 4. The answer is 1/4.
Let's look at this problem again. We wanted to reduce 30 over 120 to lowest terms. The method we used is called the method of repeated divisions. We repeatedly divided the numerator and denominator by common factors until we reached lowest terms. Well, when we divided by small numbers, like 2, 3, and 5. So there are quite a few repetitions. There would be much less work if we used large divisors. For example, in 30 over 120, let's pick as large a number as possible for the divisor, that is, 30. We divide numerator and denominator by 30. The result, 1 over 4. Remember this helpful rule. When reducing a fraction using the method of repeated divisions, try to divide by large common factors.
Like losing fat in big chunks.
Right. With fractions, though, it's easier. With weight loss, I'm not so sure. You know, Catherine, in some books, the procedure of dividing the numerator and denominator by a common factor is called canceling.
Yes, but we'll say to divide by a common factor. It's much clearer that way.
Right. Now, let's have you do some problems. Let the problems appear. Push pause, write down your answers, push play to continue. Reduce the following fractions to lowest terms. Problem 1, 10 over 16. Problem 2, 25 over 30. Problem 3, 3 over 7. Problem 4, 24 over 60. Push pause now.
The answers are problem 1, 10/16 reduces to 5/8. Divide numerator and denominator by common factor 2. Problem 2, 25/30 reduces to 5/6. Divide by common factor 5. Problem 3, 3/7 is already in lowest terms. The only common factor is 1. Problem 4, 24/60 reduces to 2/5. Divide by 12. This works in one step. It always saves time to divide by the largest possible factor.
This could have been done a longer way. Let's divide, let's say, with the common factor 2. Do this again. We get 6/15. Now, divide by 3. The answer is 2/5, as before. Yet, the first way was much faster. Only one division did the trick.
Yes, it's called reducing by the greatest common factor. The greatest common factor, or GCF, for 24 and 60 is 12. Dividing the numerator and denominator by the greatest common factor is a one-step method to reduce to lowest terms. Let's do some examples reducing with the GCF. Reduce 30 over 50. The GCF of 30 and 50 is 10. Both 30 and 50 are exactly divisible by 10. It is the greatest common factor. Therefore, divide numerator and denominator by 10. Answer, 3/5. Remember, the greatest common factor of two numbers is their largest common factor. It is the largest number that divides exactly into both numbers without any remainders.
Let's do some problems to find greatest common factors. Here are two numbers, 6 and 18. Find their factors, then their common factors, and their GCF. Then reduce 6/18 using the GCF as divisor. Now, 6 equals 1 times 6. 6 also equals 2 times 3. So the factors of 6 are 1, 2, 3, and 6. Write them in the chart. Now, 18 equals 1 times 18. 18 also equals 2 times 9. 18 also equals 3 times 6. Again, 18 equals 2 times 3 times 3. So, 1, 2, 3, 6, 9, and 18 are all factors of 18. Record these in the chart. The common factors are 1, 2, 3, and 6. The greatest common factor is 6. To reduce 6 over 18, divide by 6. The answer is 1 over 3. We call the one-step method of reducing a fraction division by the greatest common factor.
Reducing fractions and using factors are very important in understanding fractions.
Yes, but we should be very careful. Look at 2 plus 3 over 3 plus 4. This fraction has no common factor. It equals 5 over 7, a fraction in lowest terms. If someone removes the number 3 from the numerator and denominator, he has not done a proper fraction reduction. That subtracts 3 from the numerator and denominator. To reduce a fraction, we must divide by a common factor, not subtract. 2 plus 3 over 3 plus 4 equals 5 over 7. It does not equal 2 over 4.
We now turn to the topic of raising fractions to higher terms. This is really, in a sense, the reverse of reducing a fraction to lower terms. In reducing a fraction, we made the numerator and denominator smaller by dividing both by a common factor. Now, we multiply the numerator and denominator by any number greater than 1. This will make the fraction an equivalent fraction in higher terms. For example, let's raise the fraction 1/2 to higher terms. Multiply numerator and denominator by 3. This results in the fraction 3 over 6. 1/2 equals 3 over 6. The fraction 1/2 has been raised to an equivalent fraction in higher terms, 3/6.
Remember, to reduce the terms of a fraction, divide. To raise the terms of a fraction, multiply. Let's do a problem. Raise the fraction 3/5 to higher terms in 2 ways. The answer? Actually, we can multiply the numerator and denominator by any number greater than 1. So let's pick 2 and 3. First, 2. Multiply the numerator 3 and the denominator 5 by 2. 3 times 2 equals 6. 5 times 2 equals 10. The answer, 6/10. Next, we use 3. 3 times 3 over 5 times 3, which equals 9 over 15. So, 3/5 equals 9/15.
This is somehow like gaining weight, Ed.
Yeah, a person gains weight but is the same person. Here, too, the terms of the fraction are raised, but the fraction's value remains the same.
Remember, when the numerator and denominator of a fraction are both multiplied by any number greater than 1, the result is an equivalent fraction in higher terms. Now, sometimes we need to raise a given fraction to an equivalent fraction with a certain denominator. For example, Let's say we have to convert 2/3 to an equivalent fraction with denominator 12. Find the missing numerator. Look at 2/3. Now, we know that we must find a number with which to multiply both numerator and denominator so that the new equivalent fraction has a denominator 12. What times 3, our original denominator, results in answer 12? 4, of course. 3 times 4 equals 12. So, also multiply the numerator 2 by 4 to find the numerator in the equivalent fraction. 2 times 4 equals 8. So, the answer is 8/12. 2/3 equals 8/12.
Let's do another one. Change 3/8 into a fraction with a denominator 96. What times 8 equals 96? Simply divide 96 by 8 to find out. 96 divided by 8 is 12. So, 12 is the number. 8 times 12 equals 96. So use 12 to multiply the numerator. 12 times 3 equals 36. 3/8 equals 36 over 96. We've learned a lot about fractions already. It's time to do some operations with fractions.
Operations like surgery? That sounds serious.
No, not that kind. The operations of arithmetic.
Oh, like adding, subtracting, multiplying, and dividing.
Right. Let's start with adding and subtracting. We'll learn multiplying and dividing in another report. We can start by adding like fractions. That means fractions with the same denominators. Here's an example. Add the fractions 7/12 and 4/12.
Something about that example looks familiar, Ed.
That's why I chose it. Remember the 2 egg cartons you found in the refrigerator when I came for breakfast this morning?
Yes, one of them had 7 eggs in it.
That's 7/12 of a carton.
The other only had 4 left in it. That's 4/12 of a carton.
So?
So I added the 4 to the carton with 7, and I had 11 eggs in the same carton. That's 11/12 of the carton.
That's right. 7/12 plus 4/12 is equal to 11/12.
I've got it now. To add like fractions, add the numerators and keep the denominator the same.
Exactly.
Here's a problem for you, Ed. 5/8 plus 2/8.
Oh, I know. That's the 5 slices of pizza I had for lunch. 5/8 of the pie.
Plus the 2 slices I had, that's 2/8 of the pie.
Together, we had 7 slices. That's 7/8 of the pie. Okay, how about 2/7 plus 3/7 plus 1/7?
That's easy. The numerator is 2 plus 3 plus 1. The denominator is 7. That's 6/7. How about 2/9 plus 3/9 plus 1/9?
Add the numerators. 2 plus 3 plus 1. We get 6. And the denominator is 9. 6/9.
That's right, but your answer is not in lowest terms.
Oh, I see. The numerator and denominator can both be divided by 3. Well, the answer in lowest terms, then, is 2/3.
Let's give all our answers in lowest terms.
Okay, let's try 5/8 plus 3/8.
Oh, you found out that I had that extra slice of pizza, didn't you? Together we polished off 8/8 of a pizza. 5 plus 3 over 8. We've got to reduce.
2 lowest terms. That's 1 whole pie.
Just one more. Find the sum of 3/8 and 7/8.
Sum, that means to add, right?
It sure does.
3/8 plus 7/8 is 10/8. That reduces to 5/4 when you divide the numerator and denominator by 2.
Now your answer is in lowest terms, but it is an improper fraction.
Oh, is that wrong?
No, but you can also give the answer as a mixed number. Divide 5 by 4 and get the answer 1 plus 1/4. The improper fraction, 5/4, and the mixed number 1 and 1/4 are both correct answers.
Are you ready for subtraction?
Sure.
11/12 minus 6/12.
That's just like the 11 eggs I had. Then I used 6 to make scrambled eggs. So I had 5 eggs left. That's 5/12 of a dozen.
You've got it. To subtract like fractions, subtract their numerators and leave the denominator the same.
Exact.
Don't say it. Let's try some more. 12/9 minus 1/9.
That's 12 minus 1 over 9. 11/9.
Or, as a mixed number, the answer is 1 and 2/9.
Can you do 19/8 minus 3/8?
Sure. The answer is 16/8, which reduces to the whole number 2.
Can you guys take a break for a minute? There's a call on line 3.
Hello, Catherine Stalter speaking.
Hi, this is Andy, the handyman. I'm doing a big job at the boss's office at ABC Steel, and I need your help.
But we're in the middle of a report on fractions here.
I know! That's why I called. The boss is getting some new shelves. They're 5/8 of an inch thick, but they've got some fancy coating on them that's 1/4 of an inch thick. I don't know how thick that makes them, and I can't figure out how to hang them. And the boss will hang me if I'm not ready to hang those shelves in 10 minutes.
Look, just add the 2 fractions and call me in the morning. I've got a report to do.
Wait! Don't hang up yet. 5/8 and 1/4 are unlike fractions. They don't have the same denominator. I watched your report during my break, but you never explained how to add unlike fractions.
Look, let us get back to work and we'll show you what to do. Goodbye.
Now, what was that all about?
Adding unlike fractions.
Okay, then let's start. Unlike fractions are fractions with different denominators. Can you think of a good addition example?
Yes. How about 5/8 plus 1/4? If the fractions had the same denominator, we would know how to add them.
Let's try to change one of the fractions so it will have the same denominator as the other.
5/8 cannot be reduced to fourths, but 1/4 can be changed into an equivalent fraction with denominator 8.
That will work. 4 divides 8 evenly. The quotient is 2. We'll multiply the numerator and denominator of the fraction 1/4 by 2. The new fraction is 2/8. 1/4 is equal to 2/8.
Now it's easy. Adding 5/8 and 1/4 is the same as adding 5/8 and 2/8.
That looks familiar. It's just like the pizza problem we did a few minutes ago. We add the like fractions. The numerator is 5 plus 2, which equals 7. The denominator is 8. The answer is 7/8.
Yes. Oh, you're welcome. No, don't mention it. Just keep on watching.
By the way, the denominator we used, 8, is called the lowest common denominator, or LCD, for this problem.
A common denominator for a set of fractions is a number that can be divided evenly by all the denominators in the set.
Right. For this problem, we could have used any number divisible by 8 and 4 as the common denominator. Instead of 8, we could have used 16, 24, 32, 40, etc. But 8 was the lowest number that worked. Using the lowest common denominator, 8, made the problem a lot easier.
Let's summarize. The lowest common denominator for any set of fractions is the lowest number that can be divided evenly by all the denominators in the set.
Now, here's the rule for adding unlike fractions. Find the LCD. Write the equivalent of each fraction using the LCD. Add the like fractions. Then simplify if possible.
I'd like to know more about how to find the lowest common denominator.
Let's try a few more examples. Then we'll give the rule. Do you recognize this problem? 7/12 plus 1/3.
Where have I seen that problem before? Let's see. The LCD for this problem is 12. That's the smallest number divisible by both 12 and 3. We leave the fraction 7/12 unchanged.
But we convert 1/3 into an equivalent fraction with denominator 12. Both the numerator and the denominator of the fraction should be multiplied by 4. 1/3 is equal to 4/12.
We add the like fractions 7/12 and 4/12. Now the problem looks familiar. It's exactly the same as the egg problem we did at the beginning of our report. 7/12 plus 4/12 equals 11/12. Time to cook up a new example, don't you think, Ed? Try 1/3 plus 1/2.
This time, neither of the denominators is a common denominator. 3 can't be divided evenly by 2, and 2 certainly can't be divided evenly by the larger number 3.
But 2 times 3, or 6, is a common denominator, and 6 is the smallest number that is divisible by both 2 and 3. So 6 is the LCD.
Let's write the problem vertically. Now, change 1/3 to the equivalent fraction 2/6.
And change 1/2 to 3/6.
Add the like fractions. The denominator is 6. The numerator is 2 plus 3, or 5. The answer is 5/6. What's the LCD for the denominators 3, 4, and 8.
Start with 8, the largest denominator in the problem. It's not the LCD because it can't be divided by 3.
So, we then try 2 times 8, or 16. But 16 also can't be divided by 3.
Then try 3 times 8, or 24. That works. 24 is the smallest number that is divisible by all the denominators 3, 4, and 8. So, 24 is the LCD.
Great. Now, let's use those denominators in a problem. Suppose you try to make a drink with 2/3 of a cup of milk, 1/4 cup of chocolate syrup, and 1/8 cup of mint flavoring. Will it all fit in 1 cup?
Let's add the fractions. 2/3 plus 1/4 plus 1/8 and find out. We already know that the LCD is 24. 2/3 equals 16 24ths. 1/4 equals 6 24ths. And 1/8 equals 3 24ths.
The sum is 16 plus 6 plus 3, or 25, over 24. Change the improper fraction 25 over 24 to the mixed number 1 and 1/24.
So it won't fit. What you get is 1 cup of the drink and 1/24 cup mess. We should have used a larger glass.
Shipping? This is the boss. I have some orders that have to be delivered immediately. 8/15 of a ton of steel for Apex Building, 3/7 of a ton for Big Guys Construction, and 16/21 of a ton for City Supply. All the trucks are out? How about that little 2-ton truck? Of course it'll all fit, I think. Just add the fractions before you load it to make sure. You can't? Do I have to do everything around here? Oh, all right. I'll call you right back. Let me think. How am I ever going to find the lowest common denominator for these fractions? I have a headache. I'll take 2 aspirins, and then maybe I can figure this out.
Hi, this is Andy, the handyman. I'm really good at fractions now, but my boss has some really strange fractions to add. 8 over 15 plus 3 over 7 plus 16 over 21. Can you teach me how to add them quick?
The factoring method might be just what you need. Watch. Bye.
How about if we explain another way to find the LCD?
What's that?
The factoring method. Let's try to add 8/15, 3/7, and 16/21 and explain the method as we go along. Start by factoring each denominator. That means write each denominator as the product of as many whole numbers larger than 1 as possible. So we write the denominator 15 as 3 times 5. 7 is what's called a prime number. It can't be written as the product of other factors besides itself and 1. So we leave the 7 alone.
But the denominator, 21, that's 3 times 7.
Right. Now the LCD is the product of all the different factors involved in the denominators. That means we multiply the factors. The LCD is 3 times 5 times 7.
That equals 105.
Yes, but keep writing it as 3 times 5 times 7 until we have converted all the fractions. Watch. 8/15 equals 8 over 3 times 5. The LCD is 3 times 5 times 7. So we multiply the numerator and denominator by 7.
That's great. We didn't have to divide 105 by 15 to figure that out.
The result is 56 over 105.
Let me try 3/7. The original denominator is missing the factors of 3 and 5 from the LCD. So, I'll multiply the numerator and denominator by 3 times 5. The numerator becomes 3 times 3 times 5, which equals 45.
Good. Now the denominator, 21, has the factors 3 and 7, but it needs a factor of 5. Multiply numerator and denominator by 5. The numerator becomes 16 times 5, or 80.
Now, add the like fractions. The numerator is 56 plus 45 plus 80, which equals 181. The denominator is 105.
If we change the improper fraction to a mixed number, the result is 1 and 76 over 105.
Phew, those were strange numbers. Let's review the factoring method using some other denominators.
All right, we'll find the LCD for the numbers 12, 10, and 6. Start by factoring 12.
12 is 4 times 3, but it's also 2 times 6. Which should I use?
You can start with either, but notice that they both factor again. 4 can be written as 2 times 2, so you have 2 times 2 times 3.
6 can also be factored. Factoring 6 as 2 times 3 also gives 2 times 2 times 3. Do you always get the same result no matter how you start factoring?
Yes, when you have factored completely so that all the factors are prime numbers, you get the same result no matter how you began factoring.
That's good. Let me do the other denominators. 10 equals 2 times 5. And 6 equals 2 times 3.
The LCD is 2 times 2 times 3 times 5, which is 60.
Wait, I understand why there are factors of 2 and 3 and 5. But why do you need to repeat the factor 2?
That's because the factor 2 appeared twice in the denominator 12. The rule is the LCD is the product of all the factors involved in the individual denominators. Each factor is repeated the greatest number of times it appears in any one denominator. Let's look at one more example. The LCD for 2, 4, and 8.
That's easy to do by our first method. 8 is the largest denominator, and it's divisible by all the other denominators. So 8 is the LCD.
Right, but let's see how the factoring method gives the same result. 2 is a prime number. We can't factor it, so we leave it alone. 4 equals 2 times 2. And 8 equals 2 times 4, which factors again as 2 times 2 times 2. The only prime factor we have used is 2. It appears once in the number 2, twice in the number 4, but it appears 3 times in the number 8.
That sets a record.
Yes, it does. And it tells us that the factor 2 must appear 3 times in the LCD. The LCD is 2 times 2 times 2, or 8.
We've spent a lot of time learning to add unlike fractions. We should have an easy time subtracting unlike fractions.
I was thinking of an example we used before. We added 1/3 and 1/2. Let's subtract 1/3 from 1/2. Be careful. That's 1/2 minus 1/3.
We already know that the common denominator is 6, and that 1/2 equals 3/6. 1/3 equals 2/6.
So 1/2 minus 1/3 equals 3/6 minus 2/6. That's 3 minus 2 over 6. The answer is 1/6.
Let's picture the result as we did before. Start with 1/2, or 3/6. Take away 1/3, or 2 of the 6ths. We are left with only 1/6.
The rule is to subtract unlike fractions, find the LCD, write the equivalent of each fraction using the LCD, subtract the like fractions, simplify if possible.
I got another question for you. Remember the trip to school we talked about earlier?
Yes. The trip to school was 4/5 or 8/10 of a mile. The trip home was a shortcut, only 7/10 of a mile.
Okay. How much longer was the trip to school than the trip home?
Oh, that's easy. Take 4/5 minus 7/10. That's 8/10 minus 7/10, which is 1/10. The trip to school was 1/10 of a mile longer. Here's a challenge for you. Remember the student who spent 1/4 of her money for clothing, 1/5 for books, and 3/10 for food and entertainment?
I remember. We added the fractions using the LCD 20. That was 5 over 20 plus 4 over 20 plus 6 over 20, which equaled 15 over 20, or, in lowest terms, 3 over 4.
Right. Now, if 3/4 of her money was spent and the rest was saved, what fraction did she save?
Common sense tells me that if 3/4 was spent, then the rest of the whole, or 1/4, was saved. The answer has to be 1/4. But I'm not sure how to write that down.
You are taking the difference between the whole amount, that's 1, and the part that was spent, that's 3/4. Taking the difference means to subtract. You have to subtract 3/4 from 1. So we write 1 minus 3/4.
Now what?
Remember that 1 can be written as a fraction using any denominator. So 1 equals 1 over 1, or 2 over 2, or 3 over 3, or 4 over 4, etc.
I see now. We'll write 1 as 4 over 4, so we can subtract like fractions. 1 minus 3/4 equals 4/4 minus 3/4. The result, 1/4. Ed Farron here. Oh, hi. What's doing? Oh, okay. Let me write that down. 2 and 1/12 dozen. And 1 and 5/12 dozen. Do we need all that? Oh, okay. Fine. I'll see you later.
Well,
Donuts. My wife wants me to bring home 2 and 1/12 dozen filled donuts and 1 and 5/12 dozen plain donuts for my son's party.
wow, I mean, how many donuts is that?
Well, we'll have to add the mixed numbers.
I thought we'd be up to that by now. 2 and 1/12 plus 1 and 5/12. We can add the whole numbers 2 and 1 to get 3. Then add the fractions 1/12 and 5/12. That's 6/12, which reduces to 1/2. The answer is 3½ dozen donuts.
That's easy enough. To add mixed numbers, add the whole numbers, then add the fractions. Then simplify if possible. Combine the results. One and 1/4 dozen powdered. Sure.
I know. So we add 1 and 1/4 dozen more to the 3½ dozen we had before.
This time, we have unlike fractions. The LCD is 4. So, we'll change 1/2 to the equivalent fraction 2/4.
Add the whole numbers. 3 plus 1 equals 4. Then add the fractions. 2/4 plus 1/4 equals 3/4. That's 4 and 3/4 dozen donuts.
Yes? 1 and 5/6 dozen cinnamon. Now, you sure? That's all. Okay. Add 1 and 5/6 to the 4 and 3/4 we have already.
The LCD is 12. So the fraction 3/4 is changed to the equivalent fraction 9/12. And the fraction 5 over 6 is changed to 10/12. Now add. The whole number part is 5. The fraction part is 19/12.
Correct. But 19/12 is an improper fraction. Change it to the mixed number 1 and 7/12.
Now combine 5 with 1 and 7/12. The result is 6 and 7/12.
Let's be sure to remember that. To add mixed numbers, add the whole numbers, then add the fractions. Simplify if possible. If the fraction is improper, convert it to a mixed number. Combine the whole number and fraction parts to get the final answer.
Yes. How are you? No, I'm sure he won't mind. Not at all. 1 and 1/12. Okay, I'll tell him. Bye. That was your wife. She was afraid to tell you. Several of the children won't be able to come. There's a chickenpox epidemic. So subtract 1 and 1/12 dozen donuts from the order.
Oh well, it was time to try subtracting mixed numbers anyway.
Let me try. At last count, we had 6 and 7/12 dozen donuts. Now we'll subtract 1 and 1/12 dozen donuts. 6 minus 1 is 5. 7/12 minus 1/12 equals 6/12, which reduces to 1/2. You need 5 and 1/2 dozen donuts.
That looks right. To subtract mixed numbers, subtract the whole numbers, then subtract the fractions. Simplify if possible, and combine the results.
Hi. Yeah, you did say 1 and 1/12. Oh, you meant 1 and 11/12. No problem. Bye-bye. Would you mind subtracting 1 and 11/12 from 6 and 7/12?
I'll subtract the whole numbers. 6 minus 1 is 5. Now you can subtract the fractions.
Wait a minute. The fraction we want to subtract, 11/12, is larger than the fraction we want to subtract it from, 7/12.
You're right. We need to get more twelfths in the number we're subtracting from. The number we're subtracting from is called the minuend.
How do you get more twelfths in the minuend?
You borrow 1 from the whole number 6 and change it into twelfths.
Show me how.
Write 6 as 5 plus 1. Now, the minuend is 5 plus 1 and 7/12.
Then we can change 1 and 7/12 to the improper fraction 19/12.
We're ready to subtract. 5 and 19/12 minus 1 and 11/12. The whole number part of the answer is 4. The fraction is 8/12, which reduces to 2/3. I have to buy 4 2/3 dozen donuts.
By the way, do you know what 4 2/3 dozen donuts is?
A nuisance.
I meant how many donuts? 4 dozen is 4 times 12, or 48. Then 2/3, or 8/12 of a dozen, is 8 more donuts. You need 56 donuts.
Terrific. Can you summarize while I go get them?
Sure. To subtract mixed numbers, subtract the whole numbers, and subtract the fractions. Simplify if possible. Combine the results. Be careful. If the fraction in the minuend is too small, borrow 1 from the whole number in the minuend. Combine the 1 with the fraction in the minuend to form an improper fraction. Then subtract as usual. Okay, I'll tell him. Bye-bye. Well, there's good news and there's bad news about the donuts.
What's the good news?
Well, we learned a lot about adding and subtracting fractions.
What's the bad news?
You don't need the donuts. The party's been canceled. Your son came down with the chicken pox. We hope you've enjoyed our report and found it helpful. Knowing fractions helps you in real life.
Watch this as often as you need to fully grasp the concepts and the techniques presented to you. Hello, this is Ed Farron.
And Catherine Stalter, bringing you the third in our series of reports on fractions in real life.
Our topics will be multiplication and division of fractions. And we'll be seeing how our friends, the chef and carpenter, use multiplication and division of fractions in the kitchen and at work.
In everyday English, the operation of multiplication is often denoted by the word of, as in half of a slice, or 1/3 of a cup.
The rule for multiplying fractions is a simple one, with 3 parts to it. First, multiply the numerators. Next, multiply the denominators. Finally, if required, reduce the result to lowest terms.
That looks easy, doesn't it?
It is, Catherine, with practice and study.
So, let's do some practice exercises. Here are a couple of examples. Example 1. Multiply 1/3 times 1/4.
Step 1. Multiply the numerators. That's 1 times 1. Then, multiply the denominators. That's 3 times 4. The result is 1/12, or 1/12.
1/12? That means it's smaller than either of the original fractions.
That's right, Catherine, because you're calculating 1/3 of 1/4. Think of dividing a quarter of a pie into 3 equal parts. Each one of those parts is 1/3 of 1/4 of the pie. That is 1/12 of the whole pie.
Very good. Now let's do example number 2. This time we multiply 2/3 times 3/4. First, we multiply the numerators. That's 2 times 3. Then we multiply the denominators. 3 times 4. The result is 6/12. 6/12 reduces to 1/2 when we divide the numerator and denominator by 6. So, 2/3 times 3/4 equals 1/2.
Now, let's see how a chef uses multiplication in a diner downtown.
May I suggest a delicious 3-egg omelet made with 1/8 of a pound of cheese?
That sounds nice, but can you do it with just 1 egg? I'm not that hungry and I'm on a diet.
But of course, I can make a delicious cheese omelet with 1 egg and 1/3 of 1/8 of a pound of cheese.
How much cheese is that?
1/3 of 1/8 is 1/3 times 1/8. That's 1 times 1 over 3 times 8. And that's 1/24. Your omelet will contain 1/24 of a pound of cheese.
That sounds great. I'll take it.
Coming right up. To get the cheese, I've taken this 1-pound block and divided it into 8 equal pieces. Each piece is 1/8 of a pound. That's what would go into the 3-egg omelet. To make your omelet, I'll divide this into 3 equal pieces. I'll put this piece of cheese in your omelet. Can you remember how much it weighs?
No need to remember. It's just one simple calculation. I multiply 1/3 times 1/8, which is 1/24. It weighs 1/24 of a pound.
Precisely.
Diets need fractions to work. Please fix my omelet so I can eat.
Yes, ma'am. 1 egg, 1/24 of a pound of cheese.
In multiplying fractions, it's often easier to remove common factors in the numerator and denominator before multiplying. This is called simplifying. We divide the numerator and denominator by the same common factors. This is the same procedure we used to reduce fractions in an earlier part of the math report.
For example, suppose we want to multiply 3/8 by 4/6. This equals 3 times 4 over 8 times 6. We simplify by dividing numerator and denominator by common factors. Can you find any common factors?
Yes, 3 is a factor of the numerator and denominator. So let's divide by that.
Anything else you think we can do?
Yes, you can divide the numerator and denominator by 2.
Or, better yet, by 4. I always like to divide by the largest number possible. It gets the job done much quicker. It's always good to save time, Ed.
Okay, let's divide by 4.
Any more factors to use?
Nope.
So we multiply and get 1/4. And that's in lowest terms right away. We did a good job in simplifying. So whenever we simplify as much as possible, the answer will be in lowest terms. But if we miss some simplification, we'll have to reduce the answer later to lowest terms.
Pay now or later. You've always got to pay.
We now know how to multiply fractions. How do we multiply mixed numbers?
There's just one simple rule. Mixed numbers must be changed to improper fractions before they can be multiplied.
Now let's look at an example. What's 2 and 2/3 times 1 and 3/4? 2 and 2/3 is equivalent to 6 plus 2 over 3. And that's 8/3. 1 and 3/4 is equivalent to 4 plus 3 over 4, which is 7/4. So we multiply 8/3 by 7/4. That's 8 times 7 over 3 times 4. Now we have a choice. We can multiply and then reduce the answer, or simplify first. Let's simplify first. Divide numerator and denominator by common factor 4. The numerator now is 2 times 7, and the denominator is 3 times 1. Then multiply. The answer is 14 over 3, which is an improper fraction. This can be written as 4 and 2/3. So, 2 and 2/3 times 1 and 3/4 equals 4 and 2/3.
Let's do a verbal problem. If Jack drives at an average speed of 48 miles per hour for 2 3/4 hours, how far will he go?
Maybe nowhere, Ed. Maybe he's driving in circles.
Assume he's driving straight along the highway.
Then we'll have to multiply 48 by 2 3/4 because distance equals rate times time traveled. In our case, that's 48 times 2 3/4.
Let's first change 2 3/4 into an improper fraction. 2 3/4 equals 11/4. Now, multiply 11/4 by 48. This equals 11/4 times 48 over 1. Let's simplify before multiplying. 4 is a common factor of the numerator and the denominator. So, divide the numerator and the denominator by 4. The problem becomes 11 times 12 over 1 times 1, which equals 132 over 1, which equals 132. You know, the multiplication wasn't hard, but sometimes I get confused with the distance formula. Is there an easy way for me to remember to multiply rate by time to get distance?
Yes. Did you notice that we said Jack's rate was 48 miles per hour? Now, per means to divide. Let's write the rate as a word fraction, miles over hours. Now, when you multiply by hours, you get the miles or distance Jack traveled. So the formula is distance equals rate times time.
There are many uses for the skills we've just learned. Let's report now on a carpenter who has to multiply some mixed numbers at work.
Okay, let me tell you what I want. Give me 3 shelves 32 inches long. They should all be made 1/2 foot wide. Will that take a lot of wood?
I'll do a little multiplication and find out. I want to find the number of square feet of lumber required for your shelves. 32 inches is 32/12 of a foot times 1/2 foot times 3 shelves. First, I write 3 as 3 over 1, so it looks like a fraction. The product equals 32 times 1 times 3 over 12 times 2 times 1. I hate multiplying big numbers, so it's simple. Simplify. 2. That's a common factor for sure. I get 16 times 1 times 3 over 12 times 1 times 1. Now, I'll go with 2 again. No, take 4. Divide by 4. I've got 4 times 1 times 3 over 3 times 1 times 1. Anything else? Yep, there's a 3. Divide by 3. Now it's 4 times 1 times 1 over 1 times 1 times 1. That's as simple as I can make it. Boy, that was fun. Okay, the answer is 4 over 1 or 4. 4 square feet of lumber is what it will take.
That sounds all right to me.
Very good. I'll go place the order. What wood would you like?
Cherry wood. That's my favorite.
Yeah, cherry wood. No problem, as long as you're ready to pay.
Of course I'll pay. You know your fractions, and it pays to know fractions.
Yes, it surely does.
It surely does. Now we come to our final topic, dividing fractions.
To explain division of fractions, we need to introduce a new concept called the reciprocal.
The reciprocal of a fraction is a fraction obtained by inverting the numerator and denominator of the original fraction.
The original denominator becomes the numerator of the new fraction, and the original numerator becomes the denominator of the new fraction. For example, the reciprocal of 4/5 is 5/4. And the reciprocal of 2/3 is 3 halves. Just invert numerator and denominator. For a whole number, we write it as a fraction with denominator 1. Then we invert to find the reciprocal. For example, the reciprocal of 6, or 6 over 1, is 1 over 6, 1/6. Mixed numbers have reciprocals too. For example, to find the reciprocal of 2 and 1/3, change it to an improper fraction. That is, 7/3. Then get its reciprocal, which is 3/7. Notice that the reciprocal of a fraction times the original fraction equals 1. The reciprocal of 3/4 is 4/3. And 3/4 times 4/3 equals 3 times 4 over 4 times 3, which is 12 over 12, which equals 1. Now we can give the simple rule for dividing fractions. To divide one fraction by another, multiply the dividend by the reciprocal of the divisor. Here's an example. What is 2/3 divided by 7/5? 2/3 is the dividend, and 7/5 is the divisor. So, you simply multiply 2/3 by the reciprocal of 7/5, which is 5/7. That's 2 times 5 over 3 times 7, which is 10/21.
Now you can try one. When the problem appears, push the pause button, do the problem, and then push play to check your answer. The problem is, what is 3/4 divided by 1/2? Push pause and write your answer. Push play to continue.
3/4 divided by 1/2 is 1.5. To get the answer, multiply 3/4 times the reciprocal of 1/2, which is 2 over 1. Simplify. Divide numerator and denominator by 2 and get 3 times 1 over 2 times 1, which is 3 over 2, which equals 1 1/2. Now, here's an interesting fraction. 3/4 over 2/4.
That's a very complicated fraction if you ask me.
Not quite. This sort of fraction with numerator and denominator that are also fractions isn't called a complicated fraction. It's called a complex fraction.
I always like to make complex jobs as simple as possible. Can you simplify a complex fraction?
Yes. Look at the complex fraction 3/4 over 2/4. The bar between the numerator and denominator indicates division. To simplify a complex fraction, divide the numerator by the denominator. So, we write the complex fraction of our problem as the division of 3/4 by 2/4. This equals 3/4 times 4/2, which is 3 times 4 over 4 times 2. We can divide numerator and denominator by 4, a common factor. And the result is 3/2, which equals 1 1/2. When the numerator and denominator contain a sum or difference of fractions, we simplify the numerator and denominator separately, and then divide the numerator by the denominator. Here's an example. 1/8 plus 3/8 over 1/4 plus 2/4. First, simplify the numerator. 1/8 plus 3/8 is 4/8, which equals 1/2. Now, simplify the denominator. 1/4 plus 2/4 equals 3/4. Now, 1/2 divided by 3/4 equals 1/2 times 4/3, which is 1 times 4 over 2 times 3. We divide by the common factor 2. This gives us 1 times 2 over 1 times 3, which equals 2/3.
Now it's time to give our viewers a chance to simplify a complex fraction. As always, when the problem appears, push pause. Solve the problem and push play to check your answer. What is 3/5 over 2/15? Push pause and write your answer. Push play to continue.
The answer to the problem is 4 1/2. To find the answer, we divide 3/5 by 2/15. That is, we multiply 3/5 times 15/2, which equals 3 times 15 over 5 times 2. Divide numerator and denominator by 5, giving us 3 times 3 over 1 times 2, which is 9/2, and that equals 4 1/2. That's the answer.
Thank you, Ed. Now we conclude our report on fractions with a look at our friend the chef dividing fractions in his kitchen.
Chef, I've got an order for 3 little cheesecakes. Each one of them has to be 1/3 the size of your regular cheesecake. Can you do it? It looks like a good tip.
No problem. I'll just divide my recipe by 3.
Is that how you do it? How interesting. Tell me, how much cheese will there be in each one of these little cheesecakes?
My regular cheesecake contains 3/4 of a pound of cheese. 3/4 divided by 3 can be written as a complex fraction, with 3/4 in the numerator and 3 in the denominator. Get it?
Right.
To simplify, we just multiply the numerator,
3/4.
yes, times the reciprocal of the denominator.
That's 1/3.
Correct. And that's 3 times 1 over 4 times 3. We can divide numerator and denominator by 3.
Right, and we get 1 over 4.
That's it. Each little cake will contain 1/4 pound of cheese.
Gosh, fractions sure are handy in the kitchen, aren't they?
I couldn't do my job without them.
Yeah, it's a good thing I learned all about them watching the real-life math television report.
It certainly is.
Now for the tip.
And that concludes our report on fractions. Tune in again to learn more about mathematics that can be useful to you in real life on the Real Life Mathematics Television Report. This is Ed Farron
And Catherine Staltaire saying so long and good calculating.